you very much. Thank you for coming. Yes, in fact, today I'd like to focus on adding some boost to our CRM systems thanks to graph analytics. We started in 2014, in fact, by partnering with a product company based in Sweden called Neo4j. And since that very moment, we started putting all our energies in spreading the knowledge about graphs. Not just about the product, because what I'd like to try to demonstrate today is that when we talk about something like Neo4j, which is again a graph database, we are more talking about network science in general. So there's lots of interest around that, and we will try to explain why we think that the world of network science is exploding today more than ever, and all the mathematics and the algos available since the very moment when Euler invented the graph theory are available for us in order to analyze and try to discover new insights from our data. So we will try to understand how having a different approach, having a different approach to data analysis based on the graph theory. LARUS is based in Venice. It was founded in 2004, 15 years ago. And now we are opening offices in many other areas, especially in Pescara, where we are building a competence center around graphs, and in Rome and Milan, because we have many customers there. Despite our idea and approach is to deliver service worldwide. In fact, we are having many projects around the world as well. And after 10 years, we started focusing on data-driven systems, on building and helping companies in building data-driven systems, because we understood that all the complexity, or most of the complexity and value around systems is in fact around data. You might have heard the concept of and the buzzword of data is the new oil, no? Because they are becoming even and more important, especially in this period. Now, if we are able to analyze and predict by looking at our data how our business should evolve, should change, maybe we could speed up and improve, or for sure we could speed up and improve the business itself. We are working in many areas, from the government to all the sectors. This is just to demonstrate that the graph theory can be applied in very different scenarios, no? From banking to telco to retail, and again the government, as I mentioned. We have many skills. In particular, we are focused on all the NoSQL technologies. Neo4j is the graph database, but we have other kinds of systems where we specialize and we are certified. We are de facto IT architects, and we have a long-term experience in terms of building business-critical systems. When it comes to working with data, validating algos rather than data analysis, we think that it's important to collaborate with the universities, and we have many collaboration opened actually, not only with the Italian universities but also with the Technical University of Denmark, where we have lots of network science experts and researchers that help us validating and defining new strategies in applying the graph theory to our business. We are part of the Italian open source network. This is especially why we are here, because the organizers, Red Turtle, are part of the Italian business network for open source. We believe in open source, of course. Our products are always open source, despite there could be a license in order to cover the 24-hour support. We have Retardo for Plone, we have Seacom for Elastic, we have SMHE for LifeRay, and many other companies belong to this network. And we all bring the concept that open source is important also for private and the public administration, not just for fun or not. And we aim to serve and provide services at an enterprise level, even if we are talking about open source. We have other partners. In particular, we are partnering with many players around data. Couchbase is a document database, Neo4j is a graph database, Linkurious is a graph data visualization tool, and Confluent is the de facto standard or best known product when it comes to data architecture, building data architectures and data streamings between systems. This is our path with Neo4j in particular. We started, and we are the very first company in Italy covering and working with this product. But let's jump a bit into the presentation itself. So first of all, going data-driven brings real benefits. This is very important because it's not just for fashion, it's not just something that LARUS is saying, but it's something that was clearly stated by the European Commission. I will share the presentation, and on that link you can see and read with me that companies that found the decision processes on knowledge about their data increase their productivity by 5 or 6%, 5 to 6%. So it's and you can see the progression in the very different and many fields of production. So if you want to become data-driven, if you want to go real data-driven, we need to understand the data that we are managing today. And it's interesting and important to say that data have changed a lot compared to the past. Modern data are completely different to what we were used to managing with the traditional relational databases. First of all, as you can see in this chart, structured data are growing. This is true, but the explosion is more about unstructured and semi-structured data. In fact, today we are forced and called to manage the text, log files, streams, tweet, and all the social networks. No? So it's important to understand that today and even more in the future, the kind of data that we will have to manage are more about semi-structured and unstructured data rather than structured data. This is why the NoSQL movement has emerged. And this is also why the traditional relational databases are not the de facto standard anymore. In fact, relational databases are more for governing and hosting and managing structured data, no? Because you may know that you in a relational database you define your structure, you define your data model, which is static, okay, and then you put the data inside it. So you are forced to predefine the structure of your data. But when you don't have a structure because you are managing unstructured and semi-structured data, then probably the relational databases are not the best option. Because we need more flexibility. The data are different. You can have articles, you can have customers with very different information and not static as we are used to knowing. And when it comes to working with data-driven systems, when it comes to managing this modern data, there's another important aspect. which is more about the network itself inside your data. All the information that you are hosting are de facto connected. They build all the complex systems. All the complex systems are de facto based on a network, and what we use to model complex systems are, from a mathematical point of view, are graphs. So a set of nodes and relationships between them. Network theory can be applied to different and many disciplines, from financial to telco to biological, so to biology, and it may be we may know better about the social network. No, Facebook and Twitter are de facto social networks, which are graphs of information. People following other people posting likes and putting likes to posts, etc. No, de facto social networks are can be analyzed via the network theory for sure. No. But you can also imagine that when it comes to a telco company, the networks, the energy electrical network is of course a network, or also for telco, when you have to call from one point to another, then you are moving the information and bringing the communication along a network, no, along a path in a network in particular. So as I was saying, complex systems are composed by many not identical elements and connected by different type of interaction that we represent as graphs. It all comes from the network theory. You might know about the 7 bridges of Königsberg, where it all started with Euler. The problem was about modeling a problem or solving a problem, which was about walking all around the city and traversing just one time all the 7 bridges. And starting from that, Euler invented the network theory. So you have the representation on the left, on the right, sorry. So graph algorithm gives you a way to understand, model, and predict the behavior of your connected data. We are more interested about understanding the system itself, how the system works, which are the dynamics inside these systems, rather than doing classical statistical approaches and algorithms, because we want to predict and understand how the system is based, it works, and how the information flows around the network. And we have many algorithms coming from the network theory, from the path finding, where you can evaluate the quality of a path, you can identify if a path exists between 2 nodes in your network, which is very typical, for example, with Google Maps. Now, when you have to go from one point to another, you just compute the shortest path, or probably the shortest weighted path, which is a pathfinding algorithm from the network theory. And then you have other algorithms which are important when it comes to analyzing your data. The centrality, so the role and the importance that some nodes has inside the network, rather than the communities. Understanding how the information, how people, how entities are aggregated inside the communities may help you to understand better the behaviors behind that, and probably understand better how to react to that situation. No? We will try to see that in the demo later. When it comes to graph theory, to applying and using graphs, we of course have some typical use cases, from real-time recommendation, because you have to when you have to propose something, for example, into an e-commerce website, you have to understand who is looking for what, and you have to understand his behavior inside the system, what he both in the past, what is looking for, which kind of product, which kind of from which company he buys, etc. No, in order and you build a network to understand that, and you can analyze the network in order to propose a better recommendation to the user. You have a master data management. You can use graph analysis in order to detect frauds. The most common and famous event about fraud detection is the Panama paper. You might have heard about that on the news and newspapers. It came from a leak. They stole some documents, tons of documents. Actually, something like 12 teradata of data were leaked. And they, in order to understand how people were able to put their money into those fiscal paradises, they reconstruct the networks and how the money flowed along a network. No, because you might imagine that when you have to move your money from here to there, then you have to traverse lots of and ask for help from lots of intermediate people, other banks that can help you moving the data up until there, no? And they reconstruct that on a network, and you can go and see and analyze the network in the website itself of the Panama Papers. Then you have lots of other use cases which I just want to skip and deep dive to our demo. So which is the value to us in analyzing the data that you have inside your CRM with a graph approach? Well, of course, we think first of all, as I explained previously, your CRM data are a complex system. You have lots of entities which are not identical, from customer to purchases, from products, and so on. And we want to understand how could you perform better, of course. Now, the aim is to analyze the data and try to catch and bring some values from the algos and all the mathematics in order to try to understand better the data that you have inside your CRM, because the more you understand the data, and the more you will be able to sell, and which is de facto our target, no? In general, we want to try to understand the data and try to be more effective when it comes to offering some products to our customer, with being somehow comforted and supported by the data, and probably we will be more effective in proposing some products rather than others, no? So first of all, the market, which is a network again, was in the past analyzed by typical and traditional segmentation approaches. For example, we may segment our market by age, no? So some booleans or some particular values, no? In this example, no, we have segmented our market between students, between teenagers, workers, etc. No? But we know that this is not working anymore, because you know that of course between the category of students you may have very and many different interests, no? Some students, some teenagers may have the idea of starting their own startup. So it's true. They have the same age, but someone want to open his own startup. Someone has other plans. No, so we need to understand better the behavior of people because teenagers is a too wide category, no? In order to understand and propose product. When it comes, for example, to a bank, we might think that in order to have more teenagers opening a bank account, we should provide a product that have as for example free of charge for your mobile phones. No, you don't pay anything in order to recharge your phone, because we think that all the young guys and students are just interested in chatting with the phone, which is somehow true, but that's not all. That's not all for sure, no, because among this category, again, we have to deep dive and understand and analyze better the information that we have inside the system, because the data are there. It's just a matter of analyzing them correctly, no, and understand better all the information. So coarse grain segmentation by age, for example, is not a competitive advantage anymore for sure. We need to focus on the customer, we need to understand and better the customer, we need to customize our proposals, we need to customize our product, we need to go to a more personalized proposition, because every people is different and we have to understand better what we have to propose to them. So your market is a network itself, no? Customer, products, offers are linked for sure together, no? There's a person living in some place, moving some money to another person. That person is paid with a credit card. When he signed a contract, all the information are somehow connected. And this is important. The graph databases and graph theory focus more on the connections between the information and the network structure rather than the single data point itself. We are more interested about understanding how the ecosystem, how the complex system works in itself, no? So let's think a bit about how we could model our CRM information. Because if we are able to transform the information and put the information inside a CRM into a graph, then we for sure will be able to immediately understand better the relationship between the entities, and given that they become much more explicit, then they are also easier to understand, they are also easier to analyze, etc. We could find unexpected interaction between the data, for example, because we can discover that the information that in theory should be disconnected are instead connected. For example, in your mind, you have sales guys covering some particular regions, no? So Lorenzo is covering Venice, and someone is covering Ferrara, and so on. And by analyzing the data, we might discover that Lorenzo is instead selling also in the closer provinces, because he is more effective, or for some reason, is selling more. So we might discover an unexpected relationship between entities, and then, of course, by applying the graph theory, we could provide new insights between the data. Okay, sorry for the Italian words. This is a real data model coming from one of our customers, where we modeled the customer relationship system, their customer relationship systems. So it's pretty intuitive, I think. Now everybody is able to read it, apart from the Italian, if someone is coming from not from Italy. So you have a cliente, a customer, which is buying a product, the Red Bull, which belongs to a product family. the last ball on the other side. And of course, you have an agent selling a product. The agent has a supervisor, okay, which is a tree of relationship between agents up until the boss, no? And agents work for a specific agency which is based in a locality in a certain province. Okay, this is how the information de facto are connected in your system. No, this is how you could represent. It is simplified, of course. Your CRM probably have much more information inside. No, but in general, the core is that no, you have again customer buying products which are sold by some agents belonging to some agencies in some places. Okay, for sure you are missing the location and the province where the customer lives. Now you could evolve the system and add even more connection between the information, as in the example I was doing one moment ago between Venice and Ferrara when it comes to selling by locality, province, or region. The good news is for NoSQL databases and graph databases as well, is that evolving a model is much easier rather than evolving a relational database. So if you want to add a relationship because we think it is interesting, then it's just a matter of adding it without any change, without any ticket open to our database administration in order to have this relationship coming in the graph. Because the NoSQL databases that are covering again structured and unstructured data better are meant to be more flexible. Exactly in order to cover this flexibility and support the evolution of your system, of your model, of your analysis. So you can easily add and evolve the graph that is simplified here. Okay. And then you could use it to recommend product, to compute similarity between customer. I will deep dive a bit more in the demo, in particular in the second one. And then you can do many other analysis. Let's have a look at the demo. So this is the graph console for Neo4j. If we call db.schema, then we could hopefully see the model that I just highlighted, put in the slides 1 second ago. This is how the database is structured. Those are the entities present in the graph. So you could create some nodes as agents, you could create some nodes as customers, and so on. And the relationship between the instances of those entities represents real operation, real transaction between those entities. So for example, we will have an instance of customer, which could be Lorenzo, buying the red arc, buying a specific product belonging to a specific family. Okay, this is exactly the structure that I was trying to, and I represented in the slide one second ago. Okay, let's try to run our very first analysis or query. This is for recommending something. Let's try what it happened. Don't be scared about the graph. Now I will reorganize it. The tool is just for developers, so it's not meant as a front end. We have Linkurious, as I mentioned before, between our partners that are specialists in representing data in this format, in the form of a graph, but in a business way. In an end user way rather than a developer way, as the Neo4j browser, which is just meant to do some queries, is meant just for, let's say, data scientists that want to have fun with and work, not just fun, and work with our graph. Here we have two similar customers. Similars because, as we can see, they are buying some common products. So the red one are exactly the contracts, so are different by definition. Now this is my contract for, or my insurance policy or something like that. They are connected to the category, no? In order to understand that the two contracts are referring exactly to the same information in our system, no? So those are the products itself or the families, and those are the contracts de facto, no? So we can see they have one product in common, they have a second product in common, maybe even more, no? So they are pretty similar because, okay, here we are, no? Here we are. They have 4 products in common. Okay, so we are de facto computing a similarity algorithm. No, we are trying to understand. Don't worry about the language, which is not so important. I just wanted to highlight that the intersection between the product they both has to be more than 66%. No, they have to be pretty similar. No, we are interested in understanding the behavior of customers in order to be more effective in proposing some products they could buy and that we want to sell to them. No, and here the interesting thing is that those two customers, the blue balls, okay, are pretty similar. More than 60% of the things that we were able to sell them are exactly the same, no? Okay, they have in fact 4 products in common. But as we can see, we have some differences. In fact, we were able to sell to the first customer those 2 products, okay, those ones, this and this, okay, and we were able to sell on the other side those 2 other products, okay. Given on the network structure, given this network structure, then we understand that we could be effective, more effective. We will have more probability to sell something more to those 2 customers just by proposing to this customer what, according to you? Exactly those 2 products, okay? Because if we were able to sell 4 products, those ones, okay, to this customer, okay, and we know that those products interested also to this customer, in fact, he bought them as well, okay, it's very probable, okay, we have 60% of coincidence now in terms of similarity between those 2 customers, okay. So we understood that they are very similar, and so they probably have the same needs, the same interests, no, when it comes to buying something. Okay, so at this point we can try, and we probably will be more effective by proposing exactly those 2 products to this customer, and on the opposite, by proposing those 2 ones to this other customer, okay? Because they are very similar, so we understand that they share lots of interests, lots of information, no? The similarity is a concept of the graph theory. It's a set of graph algorithms, okay? Then what we could do? We could run a more complex analysis, which in fact it takes much more time, because now we are exploring the entire graph, okay, in order to compute what I did in a particular use case. Now, because there, in the previous example, I just fixed 3 products, okay, or at least 3 products, and I asked to find people sharing these 3 products with similarities over 66%. Now what I'm doing, maybe I can enlarge a bit the font, of course not. Zoom in. No, zoom in, of course. Meno uguale. Ok, luckily. Okay. So from this analysis, we understand that, for example, we have more than 4,000 customers which are exactly identical because they just bought one product, the Med Best brands, etc. Okay. So when the distance is exactly 0, it means then that this set is exactly similar. Okay, not just similar, but exactly equal. No, uh, two people, both two products. Four people, both the second row, so three products. Okay, we have almost 1,000 people just buying the Euro pension tax benefit. Blah blah blah. Okay. So we understand that there are some communities aggregated around the same interest, okay? Because they are sharing exactly the same products. They both exactly the same product. Zero, the distance is in fact zero, no zero. Then we have 11 people with a certain difference, 0.25. Let's try to deep dive in these 11 customers. I rerun the same algorithm, so it just explored the entire graph in order to compute the similarities, okay, and then I filter out the. Let me zoom out a bit, meno, perché si ingrandisce. That's okay, okay. Again, don't worry about. Let's try to understand 1 second a bit more about. Okay, if I just take the product families, okay, and try to create some space in my graph, then I immediately start seeing that there are some communities of customers around the products. Okay, so of course we can see that the distance is 0.25, so they are pretty similar. Of course, the distance was not so great, so this is again interesting because if they are pretty similar, again we could probably try to propose something to those customers. Okay. Now, more or less, we see this community of customers because they are more or less sharing the same products. But we have this unconnected, or this second community, okay, which is more interested about buying these three sets. This one, and this one is for those customers, while those ones are buying 1, 2, 3, and 4 products, set of products. Okay, so coming to this representation, then again we could analyze and try to understand which are the differences between those communities of customers in order to understand if it could make sense to propose, for example, to those customers, those sets of products. We should understand why they are so they could be interested on that just by analyzing better the differences between the two communities. It could be a problem of age, it could be a problem of a matter of, rather than a problem of region. It could be the sales guy is not proposing those products, no. So we should say to the sales guy, hey, try to sell the 4 products there to that community, okay? Because the two ones are pretty similar, so you may have more probability, okay? So this is basically all. Of course, you can do geospatial and something. Interrupt me if you have questions. Feel free to. Of course, I could do some geospatial analysis just by analyzing the location, no, where the customer lives and so on, which could be another interesting information in order to compute the similarity. I could be interested in understanding if regions are similar or not, and why they differ, and so on. Okay. So this is basically all.
So, any question or curiosity? Yeah.
Yes, please.
Hi, I want to just know curiosity. How do you gather all the data and then find the
Sure,
pattern?
sure. Then it's just a matter of importing the data into the graph. No, we have all the technologies, the connectors, in order to import, to take the data from the Plone database and bring them into a graph. For sure, you have to take the information which are inside the system and copy them into this graph structure. And after that, you can do the analysis that you are interested in. I mean, if the information are huge, probably you won't be able to do that, let's say, in memory with some Python library or something like that. Of course, you can do that as well. No, it's just a matter of querying the information in memory or bringing them into a graph, as I was demonstrating here, and then just running the graph algos, which might be a library, a Python library, for example, or the graph algo hidden and present natively into Neo4j, for example. Okay.
Any other question?
When you import the data from many sources, sometimes the same client appear in the
You're
both
right.
place. How do you manage to
Okay.
join those clients in the same in the graph?
In fact, I mentioned the master data management as one of the main use cases for applying and using a graph database, because you know, complex information systems and big customers typically as duplication, have different silos where the information are replicated, and of course, when you want to do this kind of analysis, you need to identify correctly that this customer in the system is exactly this one in the other system, because otherwise the network won't be represented effectively. No? And it's an hard work. It's an hard work because you, of course, need to clean the data, which is something that we do at import time into the graph database. We try to do some cleaning. We try to understand if the customer is in fact the same, just by analyzing the name or a set of information, but nothing can help you in terms of this technology. No, it's just a matter of cleaning the data, which is an hard work, unfortunately.
Other question?
For the last thing you just say right now about data cleaning, do you use any machine learning classification?
It may help you, for sure. Absolutely. Any strategy, any approach to clean the data may come to rescue. No, for sure, because yeah, you can do some similarities between strings. You can do some NLP, for example. But of course, you're right. You could do also some machine learning and some AI algorithm, no, in order to understand if the information are exactly the same. What we do into our graph when we import the information is try again to compute the similarities, this time between the information that you have inside the nodes. No, maybe you could understand that basically those two nodes are similar, no, in terms of the information they contain. But it's better as you are proposing, for sure. I mean, we have some merging commands statement in Neo4j with graphs. Where the merge statements means try to find a similar or exactly this node, and if you find it, use it instead of duplicating it. No, it's a specific command. But in order to understand the key, the unique key that identify this customer of this product, of course, you have to apply all the strategies. And again, machine learning may help you a lot, for sure.
Other question? Okay, the time is over. Thanks, Lorenzo.
Thank you for coming.